We have many of classmates are actually sick. Some of them have COVID. Some of them have some issues, medical issues. So they attend by hopefully they are okay. Many of them are well, hopefully they're okay. Hopefully you stay safe during this period. So I guess we can start. So what's the goal today? The goal today is to finish chapter 2. There are some remaining thing we haven't covered yet. There's some correlation coefficient, and we will work on lesson 3. I don't know we can finish this, but after this we will start to give you assignment. But I'm not sure I can finish. If not, then we just wait one more week. But just you have 2 assignments for this 2 assignments for this whole course. But basically it's Python programming. So basically you apply what you learn from this class. Okay, so not asking you some theory question. Some theory question will remain at the end of the for the exam. Okay. So let me quickly review, because I guess you have been for a while, right? I guess haven't met for a while. So just quick review, right? In lesson 1, the first class, we talk about data quality, right? And lesson 2, we talk about when we got the data, how we going to start the initial analysis, right? And today we will talk about how to do it further, right? Because exploratory analysis, EDA, right, is not going to produce new knowledge. It just from the current what we have from the data, how can we learn anything from that, right? So there's nothing new there, right? Remember EDA, right? It's just like you look at the graph, right? Or look at summary statistics, give you a number or the graph and how it looks like, right? But there's no new information. You cannot say to answer the question of future, you can only answer the question of past, because this is what data shows you. You can't extend the knowledge from the past to the future. To do so, we rely on theory that we learned today. Okay, after we finish this set of slides, talk about estimation, talk about hypothesis testing. That is to extend the knowledge from the past to the future, or what we know from the small part to the big part, small picture to big picture, from past to future. So that's what we do today. Okay, but let's review what we have done, right? So the graphical analysis, we look at the graph, look at the table, right? We learn the Excel, sorry, not in the Python, how to work those. I hope now you would be more comfortable to seeing NumPy and Panda, right? Panda is our friend, able to download data, right? And NumPy is our friend to handle numbers, right? NumPy, right? NumPy, right? NumPy is the data to control, and then hopefully you remember the LOC is try to collect data, right? And we learn how to do we learn our new friend that's last time we met is the Matplotlib library, is the Python to draw things. Okay, you will be using this for your assignment. I asked you to draw graphics. So basically you would just change something here and there to satisfy what I want you to do. So you will be, the assignment will be very close end. So I tell you what exactly you want to do. So you just follow what I want I to do and just do it. Okay. So I would say the assignment is not very hard. So potentially, if you use very advanced AI, it will give you the answer. But I do recommend you try first rather than just ask AI to do what to do, because I can't really check whether you use AI, but because it's very easy, right? So, but I hope you would not be using AI just the first round. Otherwise, there's no point of giving the assignment, right? And then also I talk about another package called Seaborn, which is a more advanced version of Matplotlib, which is the advanced version built on that, so you can draw the graph very quickly, like this style. And you can draw a much nicer one. And you can, I talked about last time, You go to the gallery, you can see a lot of nice drawing you can follow from. Okay. And after that, we learn the EDA. The main part is you look at data, right? Does it fit what we want, right? That's why we want to draw graph. The graph tells us whether there's some outlier, there's some irregularity to see the data, whether it fit what we think, right? If you think the data is not something we want, because often the data contain a lot of rubbish, and say suppose this is not something we care, then because it's too far away, because remember this hotel data, right? We want to go to a tourist hotel Vienna. Yeah, then we don't really want very far away from the downtown, right? So this is not relevant there. And then we learn how to filter data. Just one thing to remind you that there's some tricky part here because of NA. So NA will satisfy this too, because it's NA is empty, will be true. So have to follow that. And then we learn how to redraw a diagram, and this is after you clean, this is what you see, and this is what we want. So EDA involves cleaning out and filter data. Okay, that's very important part. And after you clean that up, then the next thing is to get this kind of information, which you learn in the undergrad or in other basic classes, right? And of course, once you did that, you also see maybe this is a right data or wrong data. We don't talk about that, but if you look at this, does the mean and median, all if it makes sense, right? If it makes sense, then it's fine. Otherwise, you have continue to filter the data, right? You have to clean the data until it does make sense, or you want to answer the question you want to answer. Okay, but of course, now EDA doesn't answer any question at the moment, but we don't know what happened in the past. Does this past knowledge fit what we know, right? Because you must know something about data, right? Oh, sorry, there's some people waiting. Why so many people waiting in the room? Okay, so that would be the idea there, right? I'm not going to go over details here. That package called statistics, NumPy, okay, and also SCI PY science package. You see this actually in other class. You may do machine learning, or probably the other professor also talk about that as well. But we'll do some of the package here. Okay, you want to compare data, and then it's good to look at summary statistics. Is look at the box plot, because box plot tell you max, mean, median, Q1 and Q3. So many people said today. So that was the idea. So we learned how to combine the data, right? In this one, in particular, this data set, combine the price data and feature data. Okay, and remember, this is not one-to-one matching, right? Because for one hotel, there are many days of prices, but the feature hotel is fixed, so it's many-to-one matching. Okay, so it's not using the merge function, but with the join function, what you do merge, and we use the left merge. Okay, it's many to all the row we match there, because we are using the price data. For each price, we merge this hotel data, right? What I mean is you have look at the price data, go up a little bit, right? This each hotel IDs here, right? Suppose that 2 here, and the feature data, right? We have hotel 1, hotel 2, hotel 3, hotel 4, right? Hotel 1 will match to each row there, right? So that will be a left merge. Okay, so there are many merge together, but I think for most our purpose is either one-to-one merge or this left join. So I don't think we need to talk about very complicated thing. If you learn SQL, some of you have learned that, then there will be many. Okay, iPhone 16 is coming. So that's how you merge the data. And here, once you merge the data, how you fill the data, the EDA, right? And then you want to compare two different things. So we talk about how to compare using the relative frequency, right? Then we can look at how the shape looks like in this way, or in this one, right? One is in the, this is the London, the other is Vienna, right? And then you can look at using the support idea, which is very important, is combining two plots. and you comply in the one single framework, you can see how it looks like. So it's very important when you compare and contrast. Okay, I only talk about how to do two, but you can easily check on web. You can do a lot of big grid compare. They will be very useful. Okay. And I talk about density function, which is the C bond, the KDE. Okay. And after that, I talk about how to do summary statistics, which I'm not going to elaborate. Okay. And the next thing I talk about is comparison and correlation, which is one of the most important thing about this class. Is in the second half of this course, we are going to extend the knowledge of correlation to causality. But the first thing to do is to establish correlation. Is to see whether X and Y, they move together above the mean and below the mean, how things are related, which we'll talk about this very carefully today. But last time we stopped at is we show you how to show association by graph without relying on a measure, because I think most of us are visual animals, right? We see things, see pictures rather than look at numbers, because number is not very easy to see. So that's why we talk about how do you compare using the graph, right? And last time we talked about is using the management quality survey that look at the world, how each firm is doing, and we look at, I think, Mexico, and look at whether management practice, right? And this is where we start, right? Look at the let's go again, because I think the code is worth going after again, because you will do assignment. So it's good to go again, right? So NumPy is the package to load the data. Who later you see we do it for doing the histogram. And this is the download data. The Panda will allow us, you give the URL and using the CSV to read the data from there. Once you save it, look at the data, this head. So it show you this data set. And after that, you want to select some observation. And by select observation, you do the LOC, right? Remember, if you select rows, use LOC. If you select column, use filter. Just make sure that you know what we're doing. Okay. So why I talk about that? Because this is different from Excel. Excel, the filter is filter observation, but in the Python is looking at the columns. And for the Python, LOC is trying to pick observation. So just make sure that you don't confuse, because different programming language will say different thing. Okay, here just I focus on Mexico and look at I pick it up and I tell him what kind I'm putting the filter. I will do it one by one, right? It's 1, 2, 3, and it's like I do this and I this and this and this as well, right? This is when the survey is done, and then you want this firm is not too large and not too small, right? And I don't need the NA, because every firm must have some employment level. Okay. And the management score, okay. I look at the score, look at the score number, look at the EDA, right? Look at the score first, right? This is how the score looks like, right? So have some idea what's going on. And then I look at the employment, because I want to see how to establish whether big firm is managed better or small firm is managed better, or that they're irrelevant, right? The firm size doesn't affecting the management score, right? So you try to do is look at how the shape looks like, right? The employment looks like this, okay? And these are all the datas. And you can also calculate the summary statistic based on what we learned in the class before, right? And then this is a management score there, okay? And the scatter plot, which is by Matplotlib scatter, tells you this is the shape, okay? Seems to be not very entirely clear. Seems this is okay, and this is okay, right? Maybe slightly positive, but this part is very few data, so we don't really see that clearly, right? So the scatter plot seems to be usually a good thing to see, but in this context, doesn't work. So this is a good example, because usually scatter plot can tell you a lot of stuff. But in this example, scatter plot doesn't clearly show the relation. So that's why in the textbook, they actually don't use scatter plot. What they do is, instead of looking at this data, you group them into 3 different sizes of the firm, right? Because why they do that? Because these firms are all manual firms are concentrated here, right? So there are two, not much thing you can tell from this one. Okay, so that's why if you look at what we do last time is instead of making an even split, right? You can look at it as you divide them into 3 different type of firm, right? And you put half of the firm is medium, and 1/4 of them is small, and 1/4 of them is large. Of course, you can do a 4 equal division, right? You can small, medium, large, also fine, right? But just this is more clear, okay? And am I right? I think you're right. I think some of you mentioned to me that I somehow do the number incorrect, so I just change the number back so to fit what it should be. Okay. And here, how can I calculate that? Is I create 3 different bins, depend on your small firm, medium firm, or large firm. Okay, I create a number there. Okay, I create a new number. Okay, it's called employment 3 bins, right? Depending on the score 1, 2, 3. And I look at the count, look at how many firms are there, exactly what I've seen here. And then I would just calculate the mean. That's how I get a number there, okay? So already you can see even if you don't draw a graph, based on this, I think you agree, even though we don't talk about standard deviation, at least we see from the mean perspective, just look at the historical data, not talking about future. From data, we can see small, medium, and large, right? And you can see bigger the firm actually is better, right? But it's not clear from the scatter plot. So that's why scatter plot is not always useful, right? At least from the perspective of looking at the trend, this is more clear than the plot. I think you agree. And the next thing is, of course, you want to look at a distribution, not just the mean, right? You want to tell how about look at the trend, how the marks looks like. So that's why we more or less stop here, look at the scatter bar chart, okay? And we want to look at how the relative frequency done there, okay? So I think we more or less up to here, right? We would look at, first we do is, we want to, here's a filter, it's setting observation in the column, okay? We just pick the column, only look at the firms, and the 3 bins is small is 1, medium is 2, large is 3, which we have done for the program. And lean is the score, which is score 1 up to 5, is how the lean management practice there, okay? And what I want to do is, I need to calculate several things, right? We need to calculate how many firms are in each cell, because each category is a different number, right? I think small has 72 firm, medium has 156, and large has 76. So we want to do exactly calculation. So what we're going to do is I group them by this number, okay? And I want to calculate the count, which is the size is the sum. Just look at how many of them. So this is size is just in Excel, just count, okay? You count in this group how many firms there. So means you want to group by firm size and by the management score, how many firms in the same combination, right? Small firm, mark 1, how many? Small firm, mark 2, mark 3, mark 4, up to mark 5, okay? So that is what you see. It just partially show you small firm, how many firm had score of 1, how many score of 2, how many score of 3 are score 4, and you don't see 5 because there's no firm has score number 5. So it's just basically a pivot table, right? So this is, but you can see this very conveniently created in this Python calculation. And the next is, I want to calculate the total within each group, right? So I just group the data only now, not by the score, but only by the firm size, right? 1, 2, 3. I want to see how many firms are actually in small firm, how many is the large firm, and I do transform sum, so I just call the number sum, okay? By transform means that it just collapse the thing into just one single column. Okay? So that's what we create. Okay. And once we did, we want to calculate percentage because we want to plot the thing. So that's why I could percentage is how many firm, right, is in this category, right, and then over the total in this group. Then once I calculate that, I would tell how many number of firm in this first category, right? So basically, this one is doing this, right? So this add up together is 72. Okay. So what I do is I have calculate 14 over 72 for the first item. The second is 27 over 72. Okay, so on and so forth. Okay. For each bin, I calculate how many firm is actually in this. So it's relative frequency within each set of firms. Okay, so the logic is not super complicated. Although I agree, if you try to do it by yourself, can be difficult, right? But I know, but you have AI these days now. Learning program is so easy. You just ask, and you can see once you have this class, so the basic knowledge about how to create the code, so you understand whether the Python, the AI is giving the right thing or wrong thing, right? So that would be because AI, do know that AI often give wrong code. So don't fully trust AI, okay? Because I do tell experience. I do know this last year, some of the students actually give me AI code because it's wrong, and they all wrong. So I know at least some people is copying some AI. I don't know whether they use a good AI or they use some wrong AI to do the thing, or they actually is not the AI, but they just think wrongly, copy and paste from some website. So the next is because I want to do the scatter plot. So there's some weird thing have to be done is to group them in the right way. Because when you try to plot things, you want to call it category. So just I change it to using the pandas, call it categorical. Is 1, 2, 3, 4, 5. It's no longer 1, 2, 5 because I changed to category because the scatter plot is by category. It's not by number. So I just changed the number. I just changed it to there. Okay, there's nothing new, but just for the plotting purpose. So that you can see that nothing changes in this data. So at the end, I want to look nice. Instead of calling 1, 2, 3, I call it small, medium, and large. So there's nothing new there. So just call it small, medium, large. Just replace, right? Replace it just, 1 I become small, 2 become medium, 3 become large. Nothing very deeply. I think it's very intuitive, right? Before it's called 1, I call small, medium, large. So here I have 1, 2, 3, right? In this column. And now once I do it, I come small and medium, large. So it's easier for eye to see. Good. Nothing cosmetic changes. Okay. So once I do that, then I need to do the pivot table. So it's very nice, actually, Python pivot. So the pivot. Okay. Pivot then, because I want to count, right? I want to have a, let me show you the answer first, right? I want to have small, medium, large, and this is the percentage, right? So just stack it together, right? So what I do is pivot and tell me the index, tell me the column, tell me the value. So you just send the thing you do in Excel, right? What is the row, what's the column, what the value, right? So that's what is here. Of course, if you swap that, then column and row will swap, right? This is the value you want to there. This is what is calculate. It's each group relative percentage, relative frequency there, right? So once we have that, this is a nice table. Then now we're done because given this is a table that Python understand. He can just plot the graph. Okay, and Python will tell, okay, I want to do the plot. I tell him it's bar chart, a static bar chart, and that's done. Okay, of course you are a manager, right? So basically, what you do is you ask your intern, right? Give this me, right? By 5 p.m. Then you just write down this fill out and plot and give your boss at 5:15 and go home, right? So and tell them this is the result, right? So usually, I mean, although we create things from scratch, usually many of you like manager or other thing will just, this can be given to you directly. So you don't really worry about it. Or if you don't really like Python, right, you can do Excel. Excel can output this guy, right, and can do it. But as I said, try not to use Excel, especially if you keep using the data analysis all the time, because Excel is repeat is there's no record what you have done. Python, you know the code, you can repeat easily. Excel is once you edit, you don't really, there's no record of what you've done, what you have done. So it's very difficult to replicate this, right? Because in this one, right? What's a good thing is I create this. If I have new data, just run the whole thing again, change the data, I'm done. So it's very automatic, right? So your boss wants something new. The boss say, I don't want 3 level of firm, I want 4. I can just change it very quickly. Just change the code, I feel like I'm done, right? Because if I want 4, what I'm going to do? I don't want small, medium, large, right? So what I'm going to do is instead of 1, 2, 3, I want 2, 3, 4. And then in the upper there, what I only change this line, right? To tell is 1, 2, 3 as 1, 2, 3, 4. Just change this number, I'm done, right? So quickly I do. But if you do Excel, imagine how much work you have to do again. So I do recommend if you do something once and for all, Excel is fine. But if something have to be created again, then probably this is better, right? And so once you plot that is something the graph we have seen just now. We'll be telling you the story much clearly, right? Is you go to bigger firm, each category, higher number actually get bigger, right? So that means that it does show you the bigger firm is actually perform better, at least in the lean management score. Okay. So I think this is the strongest case you can argue, right? Is in this, the firm size is related to the management score, right? And the bigger the better, okay? But of course, it doesn't answer the question yet. Is it better management lead to bigger firm, or the other way around? Bigger firm lead to better management. This is not answer, right? So we can't answer the question whether we want to expand the firm bigger, right, to improve management, or the other way around. So we haven't answered the question yet. But at least we saw they're related. Okay. So, and also, of course, if you don't like the box plot, you don't like the step bar plot, you can do the box plot and volume plot, right? So the idea is actually it's even easier, right? Because we know how to do box plot, okay? And because everything being calculated very simply, so you can just ask what the type the firm is, management score, and ask them to change according to the color of the firm, then you can plot in this one, right? Box plot is much easier. Okay. So if you don't, but this doesn't show you very nicely how this number is. So sometimes the box plot is fast, right? Because we do so many pages, box plot just do it once, right? Just 1 second, right? But I guess this has some benefit of using this long detour, right? Of this, some more information contained here. And if you change to volume plot, you can do the same. Okay. So I hope I convince you that plotting is very good to convince people to say they are related, right? And I guess the final one we want to show you is we want to show you another thing is called the bin scatter plot, which is scatter plot, but we have some tricks here. Is instead of using the raw data, we group the data, okay, and show the scatter plot. That will also make it very clear, okay. And you can see that later, the scatter plot actually show very clear trend, if you agree with that, okay. So what we're going to do is, of course, we can do 3 bins, but that would be too raw. So we do 10. Of course, we can change to 15 or 20 also fine, because different data set. But what we do is you divide the data into 10 different bins, right? So the first 10%, next 10%, so on and so forth. You have 10 different groups. Okay. You divide them based on the firm size. and you plot the scatter plot based on this data point. Okay, so that is what we do. And you can show the trend easily. Okay, what we're going to do, so we'll use a function, okay, which make us cut into 10 different pieces, okay, by the number. That's called the Q cut. Okay, so I cut the data, okay, and cut it into 10 different pieces. Okay, so what it does is the quantile cut. So basically, you will cut into 10 different things, and each group will have more or less similar size. Not exactly the same, but you should expect something similar. Okay, so that is the idea behind. And here, what you do is when you cut into 10 pieces, we want to look at in this group using the group by them, look at the mean, max, median, standard deviation, and size and number. So you would look at this is look at the mean, median, standard deviation. This is by group of 10. Okay. Some of you also puzzling why shouldn't it all the same number, right? Because of the it's an integer issue here. Because this 180, there are a lot of observations exactly 180. So that is they put in the same category. So because you cut it in a way, say you cut the data from 0 to 100, right? You say suppose the data is from 100, 0 to 10 will be the first group, right? But there are many data on the 10, right? The same number there, right? So that's why it looks like this. Suppose you should cut everything to the same, but there's some issue data bunching at the same number. So that is some problem there. But anyway, this is what we do. If the data is big, you don't have this problem. Okay. So once we're going to do, okay, is we will have I think there's something a little bit tricky. This is a tricky step here. Okay. Here is I have this column, which is something not very nice. I want to replace this thing by the mean number, right? I call the group. This is given the range, right? I want to replace by the mean. Okay, that's what I'm going to do, because this is not really, if you're happy with this, it's fine. But usually we want to plot, right? Where is the dot must be in the center, right? I want to plot based on this data. So what I'm going to do is I replace this column, okay, by the mean, which we just create, right? And because this is the vector, so you have to use change to the data type called dictionary type in order to fit there. Okay, and I don't want to explain this. It's a little bit difficult. You have to understand what the data structure. So if you do this, is keep this one there. I can't really explain, because if you want to explain, I need to explain the data structure. So just take it as given in order to do it. Okay, and then once I do it, okay, I want to group them. I want to calculate the mean. Okay, you will see there's nothing, but I replace this to here. Okay. And once I did that, I just want to plot, right? I want to plot it. Okay. And what the plot is, I want to look at the data, okay? Group them by the 10 group there. And for each group, I want to calculate the management score, right? Because I want to plot based on, I group them in the data of 10, right? Look at size of the firm, and I replace all the observation in the group by the mean of that group. Okay. And then I want to, for each group, I look at the management score. Maybe I just draw a picture easier to see. So what I'm doing is like this. Maybe a little bit puzzle to your mind. So basically like this. Okay. I have a bunch of data here. Okay. I don't know, whatever. Okay. This is the firm size, employment, and this management score here. Okay. What I do is I look at my data. I cut this data into 10 different pieces. Pieces 1, pieces 2, up to 10. Okay. 1 up to 10. Okay. And for each group, I calculate the mean of the employment. Right. Can I use this? Let's try. Oh, there. This. That's good. See if I can. Yeah, this employment, mean of the employment, right? Group 1 and so on and so forth. Look at the mean, right? And so on and so forth, right? Employment 2, right? Then what I do is this number, okay, I move to the center, move to the mean. Once I calculate, I move everything to the mean. Okay. Move to the center. Okay. And then for each thing in the group, I calculate average management score there. Right? They only left 1 point there. Is that clear? So what I do is for each group, I calculate the management score. Right? So I left with 1 point here. Here I left 1 point here. Right? So I calculate here, here, here. Right? That's what the mean said. Right? The mean is centrally located location, go up and go down the same distance. That's the mean. Right? So that's what I do in the slide there. Right? Is I calculate for each bean. Right? I calculate management score, the vertical, this. Right? Once I do this one, right? I can do the scatter plot, right? This is the bean, this is the management score. This is the same scatter plot. I'm not going to repeat it with this. So you can see it's easy to see the trend there. Is that okay? So I hope I convinced you that the bean scatter plot is very convenient way to show this very nice result. Right? Because looking at scatter plot is too, you don't know, right? But this one is very clear. Now we know it's clear. It's going up because the scatter plot failed to show this. So but the bean scatter plot can show it. Right? So that is very important because you can't show it without properly seeing this. Okay? So we can see very strong correlation, association. Large firm is very good, not so strong for the medium and small, right? Because this is increased a lot. Here is a little bit weak, right? Not very clear, but at least you can show the big firm is improving. Okay. So after the break, we'll talk you the very last thing. Actually, you learn in the undergrad. It's called covariance and correlation, which is a way to do it if you don't want to do all the graph. If you are a person who don't like graph, you just like number, right? Which is more concrete. We will use this correlation and covariance to quantify it. And this is closely related to 2 weeks later, we run regression. Regression is the way to do correlation, but it's a much more complex correlation. Okay, so let's a break of 15 minutes as usual. Since the edge period is over, this is part of the way to handle your participation and attendance. Let's fill that in. Thank you very much. I'll see you after 15 minutes. 壞即係你攞唔係七成咪就咁咪要0分咯。我唔係七成嘅，係啊，以前係我唔會有陣時，我唔會專登去查嘅。不過如果有需要查嘅時候，我會信。喂，一開始 add up 標完咗啦嘛，一開始計啊嘛，即係而家有9堂。咁啊，3如果你有3堂，你如果嚟3堂咪可以睇你想你只要上足7大佢有7頭，佢得6堂，得6堂。就諗識咗㗎啦，識咗㗎啦。應該要跟人講。我見到你，我即係睇下人個人有冇喺度嘅，經常我就唔會理嘅。不過如果你哋有其他科又唔出現啊，考試唔出現就查，睇下我聽咩事。經常我唔得閒，因為小學生，大家都咁大個，大家都俾學費啦，都唔關我事。如果打風點解要留錢？打風我哋補課咯，補課咯，但係補課嘅應該唔要學啦。我都明白，如果要補課嘅嗰啲就係 option 就唔考嘅，即係因為畢竟大家都冇到課咯，就 cut 咗個分嘅。嗱，嗰課一直落嘅話，你可以出現出納先做係，所以唔係係啦，唔好正常。你講嘅 video 咧，要嗰個咧，我非常即係如果我今晚上嘅，你係幾時？我一日咯，2日咯，咁快啊！應該都有嘅，應該都好快嘅，除非我通常都冇人睇嘅，所以唔急嘅位冇點。我即係放上去方便，我方便人食上唔到咯。即係有啲人話佢喺即係上呢個的 level 嘛，都要做 B.B.A 嘅。你都可以睇出我俾你上好多先，佢睇關鍵係當分成啊嘛。咁你即係上太少，你咪最少，你咪揾個理由，呢個即係太啦，試下啦，自己諗住佢啦，有就有就level 有嘅拎嘅，係咯，想象係自由嘅人。咁無非好似點名咁咧，咁我點名咩？大家都講到少嚟交學費咯，你交學費唔係問題咯。但係因為我哋因為個規矩係不成規矩，先可以講一科讀過啊嘛。呢個唔係我規矩都唔想嘅。咁講，而家係計食個講翻先。今天唔會多，今天剩餘時間就剩餘時間係。我第二個期佢有 KPI 就係佢 KPI 嘅用喺度寫，即係點樣計？嘢花幾啲錢咯，要計數嘅咧，因為佢冇咗成個唔會幾年時間一次啦。我哋都計嘅，行嚟幾年嘅。係啊，佢谷你個 plan 計個數，就話你呢間嘢冇勁啊，係啊，都係冇咩嘛，都係嘅。係呢個係但係評級個題，打個咩？呢個係我哋可能咩？我係用 operation。 我哋做啲有冇係做到嘢我哋咧，即係分拆即係學者佢哋對我哋講咁係即係呢個重集嘅名。係啊，冇錯。都寫住。我依家係先至可以咧，先可以。呢個關事呢個小常如果你唔合埋咧，即係你開始可能會暫時係舒緩即係我哋係明白嘛？可能就係啊，可能我同你有講，我哋一齊有分別對咪因為我先有次數手嘅，I get what you said because I forget to put on the document. Sorry. So continue your dinner if you still eating. Don't worry about that. Some of you asked me during the break that whether when I will upload the video. Usually upload video when it's there. Usually take 1 day. But actually it's uploaded long time ago, but I didn't put the link there. So I put the 6 days ago already upload. But if you subscribe my channel, then you will see. Okay. But I will try to make sure that I put the link there, but it's there already. So I forgot to do it. But if you can't find my video during the weekend, then you can just send me an email, or it should be in the channel already. So just click there; it should be there. Okay. So just try to look at this one, see whether your question. Please try to fill in if you're here or you're on the Zoom, because want to count it as part of your assessment attendance, right? So let's see what do we have. Hello, tired. I don't know what that means, but hi, happy. Good to learn more Python. Yes. Yes. I do recommend you do data cam. Data cam is really useful for you to learn Python if you know nothing. Okay. Seems to be difficult right now. So I guess it's probably you would worry about the Python code, but do remind you that you are not creating from scratch. What I ask you when you do assignment is to change the things that you need to change to fit what I asked you to do. So it's not to create from scratch, because I don't think anyone there will create from scratch anyway from the code. Basically, just understand the code, what I'm doing, try to, and then replace the one that related to that one. Okay. But if difficult, let me know. I just slow down a little bit, because if I'm going too fast, I can just cut some material out. I mean, it's more important to understand rather than I rush, because rush is no point, right? Because material is everywhere now, right? The point is understand what we cover. So if you really think it's hard, just raise your hand or use the you reply, I slow down. Okay. I do not rush. I do not rush, right? Because you have paid your tuition, I got the salary already, so why rush, right? There's nothing is going to rush, right? And the exam is going to be according to our progress. So I don't see there's no reason to rush. I haven't made the exam yet, so no rush, no cost. So if you want me slow, I slow. You want me fast, I fast. Okay, that's definitely not a big deal for me. Okay, and quite challenging. Yeah, there's some difficult because you are not familiar with that. So that's why I recommend do your homework. And I don't mind talk to your classmate about the homework. Work out together is also fine. You just submit your own version, but try not to ask AI directly, right? Because already it's very similar to your code in my slides. So basically change a little bit, you can get the answer. So try not to really ask directly. Okay. So it's very tempting, but you are not learning, right? Is Fairwood good? It's okay, but at least fast, right? Well, come on. I mean, look at the Beijing, right? Or China, right? The very expensive chain store sell the same food. So I just buy 1/10 of the price. So it's okay. I mean, I was working in Singapore, right? For 7 years. So eat the hawker center food for many years. So it's at least Fairwood's better than hawker center, I would say. So far still no video, I guess. Show me more code lab. Okay, I should do that, right? Okay, I see the question. I should run this directly. Okay, I'm sorry about that. I'll do that from the next one. Sorry about that. Oh, need coffee. Okay. So good luck with your sleep. Oh, well, okay. I think you need a coffee. Whoa, amazing. Sunny? Must be they forget now. Oh, maybe someone online is from the other part of the world. Oh, still have no idea of correlation. Yes, we will talk about now. So don't worry. We will talk about now. So I think the bean scatter plot is a very nice one because before I teach this class, I never use it. I know it, but never use it. But from this example, I know this is going to be a very nice thing. I never thought about that because for me, as a math guy, I just look at the number rather than graph. But I think teaching this class teach me how to draw a nice graph, I mean, in Python. Okay. Yes, AI code may be wrong. Actually, sometimes a lot of them are wrong, or you didn't write it correctly. Okay. Well, true, but to be honest, our class is programming rather than stat. Which part is statistic so far? Zero. Maybe now next slide is one. So far is zero. Which formula you learn? We talk about. We do we have any formula? No. Anyone statistic? No. Just coding. There's nothing about the thing. So if you complain this now after this, we will stop you statistics. So yes, transform that. Yes, the Python is the good thing. Yeah, Q cut. I think you learned there. That's good one. Okay. Okay. I guess so far speed is okay, but I mean I see that people still see I am a little bit too fast. Okay, I a little bit slow down if I can. Uh Assignment. Don't worry. Assignment is just ask you to do Python code with detailed instruction. Okay. So don't worry about that part. I'm hungry. So next time you can go to break, use 15 minutes to have a food in the firewood. That's what I do. 15 minutes I did because I was caught by TA to before I come. There is a deer in CU, is it? I saw rainbow today. Brain is empty. But that's good. Your brain is empty, though I can stuff more information to your head. Can I give assignment first? Maybe I can because maybe this weekend I can give assignment. I can give you to see the assignment first, but I still give I mean, 2 weeks of deadline. I mean, but it's not officially released. I can have a pre-release of the assignment. You can see that. Getting more. So I said jokes, so it means it's become more easy. Give you higher score, haha. But I think it's okay. Do I have member subscription? No, I don't have. There's no need to no member subscription. No, sorry. You can't bribe me. I'm not charging anything. Waiting for T8. Seriously? Okay, that's good. I hope you get a T8 tomorrow. But oh yeah, here. Can you make the matplotlib density true or false? Okay. True means you just plot the graph according to the number of data. The vertical line is a number of the count, is the frequency, absolute frequency. How many of them? But relative, when you false, sorry, true you become false is absolute. You count how many of them. But false is you divide it by total number of them. Let me show you again the graph. So go back to here. So have to go all the way back. Sorry for Going back a little bit. I'll go back. How back I'm going? Okay. You will see this is frequency is true because relative is relative to the whole set. So you can compare different data set easily. So this is only useful when you compare across data set, right? Because you normalize the vertical line, vertical, the same meaning, right? But if you don't do this true, this is also a relative number, it's true. But when you look at the number, this is false. You just count the frequency, right? The vertical line is how many in the number. If you divide the heights by total number of them, it becomes the density, true. I have answered a question. And usually, if you just look at the data by itself, you just look at the total number, right? It's more meaningful. But when you compare across data set, and the number of two data sets is not the same, you just normalize. So that's why you would compare the density. I hope I answered your question. Whoa. So it's very good. You can still have basketball match out in get paid, right? You in your work, you play basketball and come. So good for you. I never have this opportunity to play basketball while I get paid. Did you get any income? Well, unfortunately, no one subscribed to my channel, so it's zero. Still zero, absolutely zero. And I don't get any views anyway, so it doesn't matter. So it's zero. So don't worry. Whether you subscribe or not doesn't really matter to me because it's a zero revenue there. So I hope I answered a question. And as I said, I will go back to the code lab more often, as some of you want me to actually do the thing, okay, to show you how I run the code. Okay, that's okay. I'll try to do that from the next one. Okay. Now we come to the almost very end of this set of slides, because so far we just saw how things are related without calculating number, right? But if you ever learn regression, you will know that one very important tool is called correlation. It's showing that how things are related, positive or negative. Okay. So actually there will be two things we have to introduce. First is called the covariance. Now it's statistics class. Okay, covariance here. So to remind you one thing is, if you learn variance is like this, right? If you still remember, variance x is this guy, right? And summation xi minus x bar square, right? Variance is look at each observation, look at the distance from the mean, you square it, add all up, divide by n, right? It's average square distance from mean, the definition, right? It's distance, square distance from the mean, okay? Average of this distance, right? And you will see covariance is very similar to variance, right? Instead of square, you multiply by the other guy, right? Not itself, x and y, right? So x can be management score, y is the firm size, right? That's what we have seen, right? So that is how they're related, okay? And what this is capturing, okay? Just go back to undergraduate class. What it's doing? It is doing is, if this is positive, it means they are positive related. Negatively, it means it's negative related. Okay? So how so? Let me show the graph, because looking at this thing is not very easy to see. Okay? Only meaningful is bigger than 0 and less than 0. Okay? But let me show you the graph here. Okay? Look at this graph. I hope this is clear enough. Okay? So look at this scatter plot. Okay? And remember how you get the x bar? X bar's location that you look at each data point. This data point to here, this data point here, this one to here, all the distance on the left hand side, same as the right hand side. And where's y bar? is the vertical distance here, same as all the vertical distance here. Okay, this is how the x bar, y bar comes in. So naturally, your data will be decomposed into 4 areas. 1, 2, 3, 4, right? So, and now look at the area 1, which is the red one you see now here. Look at this data point. This data point is above the mean of y, on the right of mean of x. So if this minus this is positive, right? This minus this. And this minus also positive. You learn from the middle school, 2 positive numbers multiplied together, positive. Right? Same for every orange entry here. Now look at this corner, which is area 3. Okay, is this southwest part. Each number here is below the mean of x and y. So this is on the left of x bar. So this minus this is negative. And this is also below the mean of y. These numbers are negative. Middle school math. 2 negative number multiplies to each other become positive. Right? So this entry, each number positive, each entry positive. Right? So you add all the positive number, end up is positive number. So as long as the numbers are here, only must be positive. Clear? Now, of course, there are only 2 regions here. There are 2 regions. What happened to them? Okay? If you are good in math, you know it's negative. But let me explain why. Because some of you have basketball for a whole day and then we're tired. So let me explain again. Okay? Here. Okay? If you look at this data point, red, the red is above y bar. So this is positive. But this is on the left-hand side of the x bar. So it's negative. Positive times negative is negative. Conversely, or similar is here. But in this case, x is bigger than x bar. Give positive. This y is below the y bar, negative. Positive times negative, negative. So that means that when your data is almost in this region, it's negative. Right? So that means that this covariance property tells you that if positive, most of the data are here. Negative, most data are this area. Right? So it's so that whether they are positive related or negative related. Is that clear? Of course, the bigger the number, more numbers are in this region, right? Positive. More negative is more here. So the bigger is showing the stronger, right? If close to 0, then it's just basically nothing. Right? Because if 0 means numbers everywhere, right? You can't tell. You can't say. Is that clear, the covariance? What we are measuring? Okay? So the bigger the number, the stronger the relation, right? So you can go from negative very big to negative very small, right? Negative infinity to positive infinity. So the question is, how big is big? How small is small? Difficult to say, right? So statistics, okay, tells us there's a formula that can make our life easier by dividing them by standard deviation of x and y. By doing so, we are reducing from negative infinity to positive infinity to negative 1 to 1. Okay, so 1 is a straight line going up. Negative 1 is straight line downward. So let me show you the graph to stick the graph in your head. So when you see 1, will be nicely on the same line. Okay, all line up very nicely. If negative 1 is very nicely on a line. Okay, and if it's 0, it means that okay, this looks work. This seems to be okay. This is okay. You can't find it. You can't say it's positive or negative, right? It can be anything, right? So it's nothing. So if you run the regression, you can't write a line. Basically, the line is flat. Okay, but we'll talk about regression later. But if you run regression, the best fit line will be the flat one. So you can't say x and y are related. And positive means look like this. You can see a line is coming here, right? It's a fit one, it's positive. Okay. And -1 is like this one. So by showing one number to your boss, or to summarize, this is the easiest. Okay, this is what people use it, but of course, if this is so clear, I don't think you need to use this, right? The graph is good. Okay, but the graph is not good, then probably you need to use this one. Okay, I hope I answer some of the question that are there. Is that okay? So now people want me to run the code. I just run it. So we can use that SEP library. I run the data here. The data can show us covariance and correlation. Since I was asked to run, so I run. But do we have the data? If we do, we can just run from there, because I don't think it's worth your. Yeah, it's here. For the time, it's here. It's this one, right? This data, input statistics, this is data X, data Y. I just run. You give you covariance, and probably you would ask, covariance is 4, what does that mean? It means nothing, but positive related, okay? Because you can't say how strong it is, because what's meaning of 4 or 5 or 6 has no meaning, okay, by itself, okay? So that's why we care about correlation there. So when you run that, okay, that will give you what we want, okay? It's very strong. It's 0.9777, right? Is it big enough? It's big enough to see. So this is the answer there. Is that okay? So this is very strong, strongly rated. Okay. Now, very often we don't want to use this because we want to use the other one version. It's called the NumPy library. Okay, we do the same. Okay, and here you see the code here. I have one thing is you will see I have a bias true and false. Okay, and that is the reason I mentioned in the beginning. There's a sample version and population version, right? I mean, remember metaphor, right? Once upon a time, there's a girl. I want to meet her, right? I want to ask her a telephone number. I want to date her. Then what we're going to do, right? Go there and say, hi, give me your phone number. Doesn't work, right? I mean, you have to pretend, talk to her about sports, about music, about other things, invite her to dinner, and before starting to say, ask her to be girlfriend, right? That's how it works, right? You cannot go strictly. So the same idea here. You want to estimate based on data, if you want to estimate things, you have to use the no bias version. Okay? If you just want to talk about the data correlation itself, the data is already what you want to study, then use the first one. Okay? You don't want to generate new knowledge. If you use it to guess what happened in the big picture, use this past information to predict the future, you have to use this sample version, which will be clear next class. We talk about prediction, or maybe later, or we probably have time to talk about later. So, but this covariance. So basically, the covariance, the sample is like this. So the population is what we have seen. This bias is true, means this is summation x minus x bar, y minus y bar, divided by n. But this guy is the same thing in the numerator, but just the denominator is n minus 1. So the minus 1 is, and minus 1 is there. Okay? So, but the correlation coefficient has no such a thing. The turned out to be very interestingly, there's no sample version. Okay? You just calculate as you would do there. That'll be fine. Okay? So that would be the two things. There's correlation coefficient there. Okay? Is that okay? Okay. In the U reply, they told me to run the code. Doesn't ask me to type the code, so I just run the code. Okay. I'm not going to type it out. So this is the thing. I just run this. Okay, it gives me the correlation coefficient is 0.977, right? And I can ask for the covariance as well. Okay. I guess this will be fine. Okay. Now the question is, of course, we want to go back to our management case, right? Because we plot the graph already. So we really want to apply the covariance and correlation and show you the answer. Okay. So here we can show the covariance, which I will show the code later, but this is the result first. I will show you the code. The covariance of the firm size and management score is 177. Positive. What does that mean? They are positively related. That's it. We can't say more because there's no benchmark to say. You only can compare to 0. There's no benchmark. Okay. You may have benchmark if you have similar data. You look at the past, is 100, say. It's 177, now you can say stronger. But across data set, I can't say anything. Okay. Just like variance. I can't say anything compared data set. I have to use covariation, coefficient of variation, right, divided by the mean to compare across data set. Okay. And look at the SD of the two. You look at correlation will be this divided by the standard deviation is 0.3. Not very strong, 0.3, because usually it's -1 to 1, right? So when we say strong, usually it's above 0.6. Okay? 0.3 up to 0.6 is mildly okay. 0.3, less than 0.3, usually you don't say anything, right? 0.3 to 0.6 is mildly okay. Above 0.6 is strong. Okay. But it's a positive, but it's a bit weak. Okay. And okay, so it's very simple. You just look at the data and correlation coefficient the other data. Of course, you can do it one way or the other. Okay, doesn't really matter. Okay, you can do the other way around like this. Okay, or we can what we call correlation matrix. It's like this. I'm not running that, but you will, because it involves like this, right? You run this number, you swap it, also the same number there. Okay. But this correlation matrix is only useful is this diagonal, non-diagonal value, but usually this is how this related to this. This related to itself must be 1, right? So basically the diagonal are useless. Either the upper diagonal or lower diagonal, so this number there. Same as here. Scoring matrix. Okay, this is number here. Okay. I guess the main point here is one fun thing is correlation coefficient. You can do more things because it's easy to calculate. So the book tell you that, okay, why don't we look at industry by industry? Because there are many firms, you want to separate that in industry. So what we're going to do is in the data set by industry is called the SCI code, Standard Industry Classification Code, which you often appear in many data set as well. And it gives a number there. So he's just like less than, say for this case is less than 11. Okay. I call industry is food, drinks, and tobacco. Okay. This line is very compact code. Is I look at the data set. Whenever the number is less than 21, okay, I create new column called industry, which I put a string called food, drinks, and tobacco in that one. So basically I create a new column called new industry. And this column value depends on the SIC code. Okay. And the next one is same. You can see either is more than 22 and less than 23. This vertical bar is or. Okay. Is either this thing happen or this thing happen. Okay. So either it's 22 and 23 or 31. Because this has a bracket here, so it's bigger than 22 or less than 23, right? So that means 22 or 23, you can write in this way, but or you can write in this form. Okay. Then this or this thing happens. So either this thing true, that means either 22, 23, or 31. Okay, and this industry is textile, apparel, and leather. And here the rest will be similar, 24 and 27. We call this, and all the rest will be with. That is very same logic there. Is that okay? I'm not going to read line by line. I think it's very the same idea, right? This means if 28, 29, or 30, then you give to chemical, right? If 32 up to 34, right, it's called this. Is that okay? And how do you get this thing? If you go back to the data menu, right, it will tell you that SCI corresponds to this. Okay? Why I do that? Once I do that, first I can count them. I can do how many of them first, right? Look at how many firms there. And then what I do, okay, there is a, sorry, here we have a code which comes very, very ugly, okay? But if you forget about this, okay, forget about this particular crazy line, okay, this is very simple to see. I have the data. I group by industry, so I do it by industry, right? I do it industry by industry. In this industry, I look at the correlation matrix between management score and employment firm. Okay. Okay. But because I do correlation matrix, it will be something like each one I have a diagonal thing, right? A 2x2 matrix, 2x2 table, or you can say. But I just don't want anything, but I just want the number there because 2x2, the diagonal must be 1, and the other diagonal will be same number. So only get one number there. So it is a code there. So ILOC is selecting some column there, okay? And I only want the one number here. I only want the last two columns. So do I show you? So once you do it, you have this guy. Looks like this, right? Each industry, I have this table. Okay? But for each one, I just need one number there. I just need a number. Right? So that's why what I do here is I ask him, okay, for every second row, I want the second column. Then I show it here. It just means I pick this number, this number, this number, every other row. Okay. So is there any smarter code? I don't know. I try to ask AI. I try to ask the website. This is they have right now. So maybe in the future there will be one code that simplifies this. But so far it's very ugly. But what we have the ugly code here. Of course, if you don't like this thing, you can do the correlation directly, right? You can do the correlation this one, and actually it will work. But this is how people did that. So at the end, you will get this number, right? This is correlation for each industry. Okay, so that's how they give you the number there. Okay, so you will see, right? The correlation is stronger in some industry like auto, car industry, not so strong in chemical, and food and drink tobacco is not very strong. Okay, so this is by industry. So you group thing can see something, right? Before we group by the employment size, but now you can group by a third variable, right? So this is a good thing about correlation because calculation is very easy. You can group by whatever you like and calculate correlation, right? So that's why correlation is very convenient, right? Because when you plot a graph, it takes a lot of time, right? But this is very simple. Okay. Now this is the end of this set of slides. The question is, we have seen covariance non-zero. Okay. So there's some association. The question is causality. Okay. And of course, if The variation is changed by you. You do the experiment online, offline, or you decide the price, how it's being taken. Your IT manager, you change the website. You do the change. You make the changes. Any change according to your make, you see the outcome. Of course, it's causal, right? Just in the experiment, right? You control everything. You change one thing. Of course, what you see, the difference must be what you make, right? But in many cases, you don't have this. You just observe data, right? You don't actually do the changes. Maybe change do by the other manager, right? He just, because suppose you want to look at how prices or advertising affect the sales, right? But the price decision or market decision is not made by you. It's by the manager, right? If the manager is a dumb guy or a machine, he just decided based on pros and cons or do something randomly, a dumb manager, right? Then it's okay, your data will work. But the manager is not dumb, he's a smart guy, right? He's got salary there, right? So he make the pricing decision or market decision based on what he think it fit the market, right? So in that case, it's not random. Okay, so its choice is endogenous, as we see. It's just like in the data we see observable data. In that case, what you see from data doesn't tell you causality. Okay, just like in this case, right? The firm size is determined by the manager, right? How big the company is. Right? Also, the management score is also decided by the company as well, right? Because the firm decide how good manager they're hiring, right? How much money they pay the manager. So everything is unclear which caused what, right? Maybe it is because the board decide which way the company to go, right? So that is unclear. So that's why in our study, okay, we talk about this too. Okay, this is very easy. Okay, but this is something that we'll use, and often the time this is what's available, right? Because unless you're CEO, right, or you can't control how company works, right? Some people make the decision, and you use data from that there. Unless you are super IT company, right? Everything is done by experiment, driven by, just like I know that there's some IT company like Meituan or those companies, they actually do the A/B test all the time. They hire people to do it, but in general, they don't. Most companies don't do this kind of experiment every day. Right? Amazon also do experiment every day, right? Unless you do that, I think Hong Kong has no IT, right? People said. So I don't know. I mean, but you're IT manager, so you know, right? But anyway, so whether they do it every day, I don't know. Do they do it every day? I don't know. But at least I know those companies actually they do this experiment. They do, so they collect a lot of data and they see what works, what doesn't work, right? So, but if you do not, okay, you rely on data given by the others, then you can't use this. Okay, so some of you said statistics. This is statistics, but I skip for you, okay, because I don't think after the basketball play, right, I think everyone's very tired, right? So I just skip it. If you want, you can ask me or ask the TA, but I don't see the reason why we need to go for that, okay? Unless you really want me to go for it. Okay, is there any question? So far we learned the thing, just summarize a little bit, okay? Chapter 1, or the first class we talk about is collecting the data, how to clean the data. The data quality is very important, and you have to check where the data comes from. And you have to use Python to clean the data. That's the better, right? And the second chapter, or the last week we talked about is the EDA, right? How to clean the data, how to represent the data, right? See whether the data has some anomaly and try to clean it up, okay? And then we just now seen how we are going to build. The important thing is how X related to Y, okay? That build the foundation how X costs Y at the end, right? As I said, if you can control X, you cost the Y, then you're done. You can go home, right? Because you know X costs Y by yourself, you control it. Then you can just implement the policy, right? But very often we do not have that. So we need to go further, okay? So now, lesson 3, that's what we do after the break. Maybe a 5-minute break earlier, is to go from data to a bigger picture, right? We want to bring what we learned from the past to the future, learn from small sample to big population. So this is what we do, okay? And this is from small to big, okay? And hypothesis testing is also the same thing, okay? But in a reverse way. Okay? This joint data is from a small to big. And hypothesis testing is another thing, is we have some idea about what happened going on in the big thing. We use the data to see whether the big thing is what we think is true. Okay, so what is example? Suppose we want to say, okay, someone said in the website, if I change the color from white to dark background, it will improve the sales or improve the traffic, right? Or I have some nudge, right? If in the classroom, I tell people to, in the video, I said, please click like, subscribe, and like, right? You improve the people watching the video or improve that, right? If this happen, okay? And there's a theory saying that you do this, you have this. You want to see whether the data support this. So this is hypothesis testing, okay? And possibly you would ask why we care about this, okay? Because at the end of the day, you want to come up with a model to tell me how the data works, how the world works, right? And whether the model is meaningful, you have to rely yourself on hypothesis testing, right? Because from this, you give you a mathematical model, and you want to know this model really works, we rely on hypothesis testing. So these two are closely related, and all the time, all our statistics, we rely on these basic tools. If you run the regression, you know, estimating the regression is this one. And you want to see whether the regression is meaningful, is significant, the P, you have star, okay, is here. Okay, so you still remember regression, you have to 3 star or 2 star, 1 star. Okay, so let's have a break of 15 minutes, and then we come back to go to now we have some statistics. So far we haven't, now with statistics. Okay, so let's have a break of 15 minutes as usual. In case you have a question, I put the second break here. If you fill in the first one, you don't have to fill in. Just in case of question, you can fill in. But if you don't have anything to say, you don't have to fill in. Just in case of question, you can ask.因為係啦，冇講，因為我哋學嗰陣時咧有兩個原因。第一，因為有個叫做中央極限定理 （central limit theorem），就係話基本上如果啲嘢正常嘅話，就都係攞嚟標飛。但係多數都係點講咧？係得嗰兩樣。咁呢個係正常嘅，所以你大部分嘢都會有呢個。我哋追求只係話正常嘅情況咧都係防呢個。呢個係數學定理嚟。咁我點知道我嗰啲 data 本身係一個咁樣？你可以 test 㗎。譬如話你睇下 excess kurtosis 係咪大過3，細過3，全部都係 test 到。有啲 test 可以做得到，係咪 normal 嘅 test？話 plot 出嚟係咪靚仔？QQ 好多嘢都做得到，全部都 test 到嘅。哦。啱咪奇？咁如果佢唔係咧 ，which 好多時都唔係咁嘅情況咧，咁你就要用到一啲唔係正常嘅工具啦。咁我哋學我哋基本嘅課咧，就係 assume 佢 bell curve 用得到。但係如果唔係咧，我陣間會講到咧，我哋會用兩個辦法。第一個咧就係用 bootstrapping， 第二個就 resampling。咁我佢計出嚟，咁佢唔係嗰陣時有其他招數嘅。哦。咁唔係追求個人，我哋有其他辦法。明白。但係呢個辦法係難好多，所以我哋只能夠講少少啦。今日講少少，有呢個問題，就係正常情況之下咧，所有 bell curve 嗰啲嘢就會 under 佢哋 O 嘅 ，under 佢哋 O 嘅。但係如果你超越嗰啲就唔 under 佢哋。咁我哋要講有少少bootstrapping 啊，譬如 jackknife 啊呢啲，有啲辦法嘅。你問得非常早，但係呢啲係研究。我睇完之後，咁點解要咁樣講咧？有㗎，你睇到有講嘅。你有講啊？有咪我有講唔係 bell 㗎？
但係我睇唔明咯，我哋就咁 central view 之後就
因為你呢個譬如話啲 financial data 都唔會係 Bell 噶嘛，咁所以正常嚟講佢都係會用你要直接，譬如話呢個咁嘅做完，你assume 係咁 OK，但係正常都唔係咁，所以你要用呢啲會 sampling 嘅辦法咁就會做到咯，或者係做bootstrapping 咯。
但係嗰5% 係點嚟嘅？再後你要 check 某啲嘢。
你話加兩個？
唔係呢兩個，再下啲，再下啲。邊度咯？幾多呢度？呢個
5% 係話我接受5% 嘅 loss。我開始定，你可以變10或者8度。嗰個唔係我哋定，我唔可以，我 loss 唔可以超過8，我超過8之前我哋。Case want to say anything? You can just say. You think it's too far, too small, too fast, too small.
Yes,
I saw you are very diligently writing the notes. This is like now I teach undergraduates. They never print their slides. They all use iPad. No one print anything. So I'm very old fashioned. I also like it, but now no one prints. Yes. No, even though my students, even though they don't pay. Basically, it's like nobody not paying. No one paying now. No one paying anything now. Yeah, that's why we do that. Now, no one paying anything. 我係邊人嗰啲生活即係我啲北真係點係我都嗰陣時候嘅人即係我啲學生就一定要死依個係即係每日開嚟，我都係睇其實要對我嘅。呢啲成個highlight 嘅，我咪睇出嚟，我嗰個真有時。邊個啲書啊？太好啦！哦，係啊，買啲貴書啊，即係水啊，即係睇翻咯。但係我覺得你如果上台啲堂，佢睇翻呢個廢話，多長有少少，應該知道覺得。如果唔係，但係呢本書就係 master 咧，就係你定定嘅，佢分啲就係我嘅，其他係直接都係咪？所以係適合係適合你學嘅。但其實多數我覺得呢個唔錯㗎啦，我呢個科又唔算即係我有數就擺喺後邊，但係實際真係都有少數嘅頭啱睇到。我就唯一買呢科嘅就解第8個可以，浪費咗我幾周生命。
MP 团都是走什么啊？都先这样。
Never concentrate. You never compare. You never see or anything. That's like 你哋而家要上幾多年？嗱，呢個係雙啊，呢個雙飛即係發啊。低脂糖加錢。不過我唔開心，我係俾個嘉賓。因為你個 suppose 你 IT man 唔識太嘅，唔使我教我。得啦，我啲發票嘅，因為嗰時我係教大家我都如果你覺得我係錯，
A 樓多啲咯，或者係呢個
Hey. So during the break, some of you told me that my class is too easy compared to the other machine learning class. right? This my class covers something more advanced than the machine learning class, right? Some of you agree, right? So no, I'm not changing the difficulties, but I'm saying that you shouldn't complain my class is too difficult because you also learn the basic from the other advanced class, right? So you learn the basic, more advanced thing in the basic class, right? So that's okay. So I skip the dictionary, actually you know from the other class, right? So that's okay. Suggest reading for pandas. I don't think the pandas we get very complicated. Still, the only thing we do is group by, aggregate. This is the same thing. We didn't do more than we have done. As I said, if you really want exercise, go to data camp. That's the easiest you can do. That is the easiest thing you can practice. Of course, I mean, unless you're a programmer, you don't really need to learn programming, right? Just look at the code I do. If you don't understand, ask me or ask AI, they tell you what this code for, and that's it. Because you are not doing a new thing, right? If you win the new thing, ask AI or ask the menu, see how it can be done, right? So I just tell the basic thing and that's the end. I mean, I don't ask you to do the new thing yet. Okay, now understand causality. So causality means X cause Y. Okay, if you change X, you will see the Y happen, right? So it's just like if you eat, then you are not hungry. If you don't eat, you're hungry, right? So it's eating is lead to whether you're hungry or not, right? You're full or not, right? So there's a cause and effect. Causality, cause and effect, right? But correlation, right, doesn't tell you cause and effect. You don't know which cause what. Just see the example we have saw is firm size and management score. I can't say very clearly if you make the firm bigger, the management go up. You didn't say that, right? Or I didn't say if you hire better manager, your firm get bigger. No, I don't know. I can't conclude that. Okay, because maybe actually you hire a better CEO that lead to both, right? It can be, right? We don't really know what caused what. But as I said, if you are doing experiment, as you have do in the IT manager, you do A/B tests, you change your web surface, you web interface, you change things, then you lead to the changes, then highly likely this is causal. This cause and effect because you enact the changes, you make the changes. What you observe should be the result of your change. If the underlying thing doesn't change, okay, that is how we do it. All the science is being done in this way, right? You change only one thing, keep other thing the same, then the changes must be the change you make. Okay, there's no other way around, right? And the causality, we cannot do it if we only observe the data collected by others. You don't make the changes. Okay? The other people make the changes. And you don't know why they make the changes, right? Because if you remember in experiment, you apply the change randomly, right? That's how your medical test is being done, right? You have control group, your treatment group, right? And you just random how you people assigned to the treatment group and the control group is random, right? And then they don't know, the doctor don't know which group got the medicine and also the patient, right? In that case, you can say this due to the treatment, okay? And if done by others, you don't know why the price goes up. It's because of manager asked to do it, or customer asked to do it, or there's some other reason. You don't know. You can observe. So that's the reason. But anyways, don't worry. This is something that is important for our class. We will talk about that. Here we have a question. Is when we have time series data, is biased true or false? Okay. It's not about data first. Okay. It's about what conclusion you want to draw. If you want to say this thing is from your data, you don't want to extend your knowledge from what you have to the future, feel free to use population. No problem. Only if you want your data to say things about future, you predict the things, that is you need the bias is false. You divide by n-1. But of course, it doesn't really matter anyway, because you work in time data, you have a very long data set, and n-1 the same thing, so no difference. Usually no difference. Okay, but I would say when the data is time series, it is beyond the scope of a class. It's because when the data are not independent, so the data are related, and then you have to use the statistic method called time series method, which is way beyond our class. We can do this is what finance people do. Okay, and probably you ask, how can you solve this problem? Okay, how do you solve if you have time series data? Actually, you do it. If you're monthly, maybe you do it by annually data, or you do quarterly data, then you take away the how data are correlated. Okay, it become more independent. But it will the temporal doesn't affect this choice. But when the data time series, it's beyond the scope of a class, because when data related over time, then usual method would fail. But later we will see in the class, we talk about stock market, stock price data. We talk about how to control those things. Don't worry. I'll talk about how to do it, but how to do it formally, you have to take a whole class of time series to answer the question. Actually, that's how the finance people make money, right? They have to learn how the things are related. That is a highly technical subject, but I'm not going to touch it. But this is requires statistics class. Okay, but I will teach you some method how to handle that. Oh, you're hungry. So it's already 9. So hopefully you don't make you too bad. Correlation Q cut. Okay, that's fine. NumP. Speed is okay. Can easily follow. Last thing. Who play basketball? Who play basketball? Let's break end class earlier. I also want to do that, but I'm not allowed it. But I don't know the other class do it, but officially I'm not allowed to end earlier. So maybe I can try to ask if I can, but what I know is I can't. But so before we have bring empty, now we bring fire. So it's good. I stuck some fire in your head. So now we have lesson 3. So we're clearly probably I can't finish this set of slides by today. So we will delay the homework to be released next week. But as I promised, I will be trying to pre-release earlier. So you see what the thing you can try to work on it. Okay. But once you do the homework, let me know it's too easy or too difficult in the pre-release version. I can adjust accordingly. If you say it's too easy, I can make it harder. If you think it's too difficult, I can just cut out some of the question to make it easier. Okay. But let me know. Okay. So now what we want to do is to now get to the real business of statistics. Okay. Statistics is we try to extend the knowledge from the data to a bigger picture. Okay. So let's go for it. So the hook is here. So we want to generalize the pattern we saw. Okay. And the first step we want to do is we want to do estimation hypothesis testing. Okay. That is the 2 things we're going to do. Probably at least we'll do 1 today, 1 next week. And this is step 1, right? Based on data, you want to do it, right? Based on data, you want to generalize it. And the next one, which is external validity, is the data that you get going to be useful for other setting, right? Because we're never sure. So you have to use your judgment, your expert domain knowledge to see whether it applies. Okay, this is our statistics. Okay, I mean, don't think that math can answer the problem. Ultimately, you have to make a decision. Okay, math cannot tell you whether the data apply to the decision you want to do. You have to make the decision. Okay, don't blame the math. You have to make the decision. You're the manager, right? If we don't need you to make the decision, you will be replaced by AI very quickly, right? So you need to make the decision whether the result applies. Okay, I can't tell you because it's your domain knowledge. But what I can tell you the step 1, right? Step 2 is rely on you. Okay. And this is very important because usually that class don't tell you step 2. But that's most important. Right? Because whether you apply, you have to be up. You have to judge. So estimation is simply that you want to know what's going on in the big picture, which is some maybe mean, maybe variance, right? Usually the mean, right? Usually the mean variable, okay, or variance. Want to estimate that, right? You want to know, say, for example, how much people want to pay for your product, right? In that particular case, you probably want to ask some group of customer to see how much they want to pay for a product and use that data, maybe sample mean, to project, to estimate what's going on in the big population, right? So it's some trial test, right? Just ask a subset of customer to try your product and see how much they're going to pay and so on and so forth, right? Or in IT, right? You want to see the new system, how it works out, how the response time, how you're going to do that. You implement this in the local server, a local system, see how it works out in a small group of user and how the response time, how other performance work, and see if it implemented the whole system, how does it work out, right? So that would rely on this idea. Or you want to see how, when we implement these changes to this market, how this affected to the new market, so on and so forth, right? So this is from small to big, and usually in our class, make our life easy, we focus on mean and variance, okay? This is something elementary. Of course, you can pick more stuff, but make our life easier, mean and variance. The other thing will be the same thing, but just make it easier. So there will be estimation. If you still recall what you learned in the college, there are 2 ways to estimate. One is to estimate a point, a single guess, or interval estimate. You estimate a bunch of points. So that's the same thing. If I want to shoot someone, right? If I use a pistol, then it's just point estimate, right? If I'm Kim, I have a nuclear bomb, I just bomb the whole area, right? Whole region, there is an interval estimate. So whether use pistol or use the A bomb is like this, okay? So to make things easy, let's estimate based on stock price because everyone knows it. It's easy to see how to do it. So we run this code, okay? So US stock market data, okay? And what we focus on is not the price, but rather we look at change in price, okay? You may ask why I want to do that, look at the price, okay? Probably we mentioned in the beginning as well, is price is a skewed data because price, usually stock price cannot be negative, right? From 0 to infinity, right? And where you cannot go to negative, right? That means that the graph of we try to plot the price is going to be squeezed, right? It's not a bell shape. And you know from statistics from your college, we need the bell curve usually to get a good answer, right? So instead of looking at the price, you look at price changes because price can go up and down. It will be at least more symmetric, more like a bell curve, and things will get better. Okay, but of course, many times it's not a bell curve, but at least in general, this is better. So we focus on change in price. Okay, so one thing I want to say is if you want to do prediction, usually you want things more symmetric, more like a bell curve, can do things better. But that's what you learn in the high school. Sorry, high school, not in the college. Okay, but I will tell you that if it's not bell curve, how can you do? Okay, we'll use something probably new to you. Okay, we will call bootstrapping. Okay, so what I want to do is look at is I want to base on this data to see what's the risk of investing in the US stock market. Okay, how can I quantify the risk? You look at how likely that I will lose more than 5%. Okay, you can use any number, but 5% is people will want to accept. Okay, each day, daily I lose 5%. I want to calculate the percentage of day or probability that I will lose more than 5% in one day. Okay. So what to do is the data is come from S&P 500, I think 2016 data. Okay. 2016 to 2006, 2016, 10 years data, 11-year data, daily data. Okay. So as request, I run the code, but let me go line by line. Okay. Because people say I'm too fast. Okay. I slow down. If you think I'm too slow, let me know. Line number 1, NumPy is remember our old friend, this is how to make our data. Okay. I don't think I disagree. Panda is to import data. Okay. This URL and import it and stop. Okay. So just run it quickly. I run this thing. Oh, I should be logging. Why? I should have logged in. Just wait a second. So I download this thing. Okay. Sorry, I import another thing as well. And I look at the stock, look like this. Okay. It's the date, and that sends P500 data. Okay. The stock index. So it's just a one number, single number there. Okay. Now, I hope you're okay with that. Okay. This data is here. The next thing is to clean the data. Okay. Because data is not perfect. So first is what I do is I use the stock dot replace. This means that I would look at the data. If the data has no price, it's absent, which this is empty string. Okay. I mean, you learned this from the other class, right? So, and this NP is numpy.nan is not exist. Okay. And then if the data have NA, then also with NAN. Okay. And if the NA, you drop there. Okay. So you do one by one. Okay. Once you do it, you reset the index. Okay. Because the index, once you drop things, the index is not right. Because if you drop this, you 3 up and next one is 5. Right? Suppose you drop this guy, you become 1, 0, 1, 2, 4. So no 3. So we want to make the index right. So just reset the index. Because this is time series data. So we want to do it this way. So this is what we want. Okay. As request, I just run it. Okay. This is what we see, right? The 0, 1, 2 is a very nicely ordered data. Is that okay? Now, the first, as I said at the beginning, I don't want to look at price by itself. I will look at the return. I explain the reason, because price cannot be negative. So if not bell shape, usually doesn't work very well. Okay? The classical wing you learn in the college, always look at the bell shape, the normal curve. Okay? So what we're going to do is now I will impose what we call the percentage change. Okay? And that explains the reason why I need to reset the index. Because the percentage change will take to the current row minus the last row. Right? If I don't reset the index, then there's no last row, then you end up with error. So I reset index, so then I would just do it. Okay. And this, you just take this column, this what you do, percentage change will be right, you take this price minus the yesterday one, right? Over the yesterday, right? This is how we define percentage change. You learned it in the middle school, right? Or secondary school, right? That's how to do percentage change. Okay. And multiply by 100 because I want to care about percentage. And because the first day don't have change, right? You start from first day, right? So first day have no change, so you drop the first day. So that's why the NA come from the first day. The first day have no change, right? The very first data. You can't subtract the negative. It's nothing you can subtract, so you drop the first day. Now once you drop, you saw the data, which is this guy. Okay. Is that okay? So this is what we get. Is that okay for this one? So we just transform data, not the price, look at percentage change. Is that cool? Okay. Now the first thing we do, remember EDA. EDA is plot the graph first and see how it looks like, whether this fit our intuition, right? Whether it is a nice graph or not so nice graph, and try to convince this is a symmetric or nice bell shape. Otherwise, I can't do any prediction. Okay. And also, I want to look at the return because the risk is based on return, right? I'll look at 5% and how many days is more than 5% losses each day. So this is our return. I don't look at that. So what we're going to do, again, line number 1, I load Matplotlib as PLT. Okay. And what I do is I use bandwidth of 1. You can use any other bandwidth. Okay. And you can use 0.5, you can use whatever because bandwidth decides how big it is. And you use the APA range. From the minimum to the maximum, remember the Python logic, you add the bandwidth with, because otherwise you have missed something because I don't know why they do it, but this is what we have, the bandwidth. This is where you pair the bins. And in the histogram, using the return, lose the bin there, X label, Y label, title. So, I mean, I don't need to go line by line. This is easy, right? So this is a graph. Good. Now you can see the graph looks okay, not so bell shape, but at least what I expect is the negative, the positive. The bell is like that. Okay. Whether it's a normal bell or not normal bell, I don't know, but we will do the analysis based on bell first and tell you how you can do if this is not a nice bell. Okay. But let's do one first. Okay. First, look at the risk we define. How many days are 5% loss? What does that mean? It means that we want to know this is the risk. I want to calculate how many days are there. And I want to calculate percentage. So I want to know total number of days over how many total number of trading days we have. Okay. Then it's quantified as my risk. Okay. That is the idea. Is that clear what we're doing? It's the number of days that lost more than 5% per day. Is that okay? Is that okay? Okay. How can we estimate this probability? Okay. The easiest is to point estimate. As I said, use a pistol to shoot. Okay. The best thing to estimate is based on what the data is, right? Because that's called the sample mean or sample proportion, as you say. The sample mean is the best guess for the population mean. If you still recall what you learned in the college, right? The mean, you look at data, look at the mean there. That's the best guess for the population mean, right? You can imagine the same idea, right? I want to do the marketing survey, right? I want to ask how many people want to pay for the new iPhone, right? Then what you're going to do is collect a bunch of customers, ask them how much they want to pay, and average result from this group with the best guess for what we want. Okay, no need to do any adjustment. So that's what I do. Our point estimate. Okay, so how do we do that? It's like this, not something difficult. So I want 5%. Negative 5% is what we want. We set 5%. Okay, if you want to say 9%, then it will be 9. Okay, it's your choice. Okay, you don't have to 5%. You can any percent you like, depending on how risky you like in your portfolio. You think each day 5% is a very bad thing, then it's the thing. Okay, and what you do is you look at the data. Okay, and look at each day how many days less than 5%. Remember, this is the statement give you 1 and 0 because of bracket there. Okay, if the day is less than that is 1. If the day is not, it's 0. And you dot sum means you add 0 and 1 together, right? That means that how many days that the return is less than 5%. Exactly. Let me repeat. Without the bracket, this with the bracket, this will tell you for each this is a bunch of this is a return, right? This is a return is this value. What I'm going to do is compare each day is still less than negative 5. If no, 0. This is 0, this is 0, this is 0 and some days 1. Okay, and if less than that, then it gives you 1. Okay, this bunch of 0 and 1. Okay, and dot sum means I add everything there, right? And this gives us how many days are actually less than 5%, negative 5%, right? And this is total number of days. You use dot count, you should remember how many days in the data. You look at the percentage of days, right? That less than the loss is more than 5%. Okay, this is our percentage, which is 0.5% of days. Okay, that is less than 5%, right? So it's 1,000 trading day, your 5 days like this. Okay, so that is the risk. Are you willing to take that or not? It's your choice, but this is data where it shows. Is that clear? So if you use this measure, we tell you that 5%, 0.5% of days, we have that day the return is less than negative 5%. Right? Is that clear? The problem is we only have one data set, right? So we can't tell whether 5% is by chance or are you sure it's it, right? So how can we make sure of that, right? Because this is what we learned from B.B.A, right? Just know how do we generalize this new knowledge. Okay, usually we want is in principle, right? You can have many universe, right? Maybe in this universe, the subpipe goes in this way, the other universe goes this way, right? If able to have multiple universe, right, that will be easy, right? And but we only observe one universe in this world. Unfortunately, we cannot talk to the other self in the other universe, so we can't really go to the past and see what happened. But statistics tell us how we can do this problem, okay? And how to do this problem if you still recall what we learned, okay? What we learned in the college is we call standard error. Okay, so we can estimate from the data. In the data is how much variation in the data can give us some idea how good you estimate. Why is the case? If your data, suppose, okay, is very concentrated around the mean, right? The sample mean, right? Not much variation. So what the guess from the data would be accurate. For example, put it this way. Remember the example we ask the people how much they want to pay for the iPhone, new iPhone, right? Suppose everyone say the same number. So you have a strong confidence that this number will be the right one, right? With little variation data. So what we guess will be the right thing. But if the sample we got is someone say 0, someone say 1 million, someone say very different number. So the guess we're going to make is not going to be too accurate. So that is the idea behind. So as long as we know how much variation is in the data, we can give idea on how to guess. Okay? So in other words, it's with a pistol, we shoot, okay? Then the problem is how big our nuclear bomb has to be, right? If we want to bomb, right? Then if the data has a little variation, we can use a rocket launcher, it's done. You don't need a very big A-bomb, okay? Use a grenade or maybe already done, right? But your data has a large variation, okay? You have to call Kim and bomb, right? So that is the idea. That's the idea, right? So that's the standard deviation, standard error. And standard error is related closely with the standard deviation. If you remember the statistics class in your college a few years back, okay? So once you estimate this guy, okay, you know how to do it. Okay, it's related to variance. We tell you the formula. Okay, and how to create our A-bomb. Okay, it's very simple. It's just our guess plus minus 2 of the SE. if you still remember, or 1.96. I don't know, still remember the magic number. But if not, it's just 2 times of that, right? But even if you forget about that, I hope you remember a book that was very famous. It's called Six Sigma. Anyone know Six Sigma? No? Right? Sigma is the SE, right? So it's 2 SE. So everything is between 2 SE, 2 S, right? So that would be the idea. Okay. And for this to be working, you have assumed the thing is a bell curve. Okay. But very soon we talk about that. Okay. And of course, the problem is how you can get this SE. Okay. And first is you can do is based on the model. As I said, the model is very close to looking for sample variance or sample SD from the data. Use some changes as well, or we will do simulation by resampling and bootstrapping. Okay, so this is the way. And when this simulation way is good, even the data is not bell curve. So some of you ask me, what happened if the data is not bell curve? Not bell curve? You can't use the first one, use the second one. Okay, we'll tell you how to do the bootstrapping and resampling. Just 2-3 lines of code in Python, you can do it. Don't worry about that. It's not something complicated. Now, this is the formula. I'm sorry, I'm not going to derive it. This is you learn from the undergrad. Okay, this is the formula. Okay, in general, okay, the SE is just SD standard deviation divided by root n. This is very simple. So let me try to explain what it is. Okay, remember the iPhone case. Okay, iPhone. I ask people how much they want to pay for it. I calculate the mean of this group of people, how much they want to pay. That gives us the pistol gas. Okay, and now I want to make an A-bomb. Okay, then what A-bomb is, I make 2 SD of that, 2 times SE. But what's SE? SE calculated by this formula. How to do that? I calculate standard deviation from the group of people need to pay. How to calculate SD? Is the square root of variance, right? If you remember square variance, it's like this, right? I hope you remember. Right? SD is equal to square root of x minus x bar squared over n, right? This is a variance, but you take a square root. That's it. Okay? This guy, the root n, this guy. Very simple. Right? There's nothing deep there. If you forget, it's okay. But this is how we do it. Okay. And if you remember something, if you work on the binary data, so data is only 0 or 1, right? Sometimes you have binary data because you ask whether you like our product, yes or no, right? Then you can calculate in this way because this is a variance. When the data is yes or no, the sample mean is a sample proportion and just multiply by 1 minus, you get the variance. Okay, but the same formula because this when the data is 0, 1, this is exactly the standard deviation. So there's no 2 formulas, there's 1 formula. Okay, but when the data you get is just 0 and 1, then this is what you get. Okay. So let me illustrate that through this example. Your NumPy, I use the SIP there. This is my data. I can calculate the standard deviation. Okay, but of course, don't worry. You have the function directly, SEM, standard error of mean. Do this, you get what we want. Okay, so you don't need to remember the formula because it's there already. Okay, so that's why I don't tell the formula, but this is what it is. Okay, because this is the formula. This is n is 5. This raised to the power is square root. Star is the raised to the power 1/5. This is square root. Okay, so this SD divided by root n. So this is the thing, but now, so in this case, okay, in this example, the sample mean is 3 because 1, 2, 3, 4, 5. Okay, the mean is 3. Okay, and you plus 2 SE minus 2 SE. Okay, so you can imagine this is the case. This is the iPhone test group, right? So someone say I want to pay $1,000 for the iPhone, 2,000, 3,000, 4,000, 5,000, right? Say for example. Okay, then you can calculate this number, and your guess will be, on average, the guess is people want to pay $3,000 for the iPhone, right? Maybe not iPhone. iPhone is too cheap, right? Maybe Xiaomi phone, right? Mi phone, right? And then you will be going 0 to up to 2 point. Must be some mistake. Wait a second. So this must be wrong because 3 plus 0.7 is should be 4.4, right? And let me do it in Python. Yeah, so it's 4.4 and 1.5. Okay. So the data is right here, right? Because the mean is 3, then the SC is 0.7, so you just add 0.7 times 2 and minus 0.7. This is the guess. So you will be guessing people willing to pay for the Mi phone for $3,000. If you are only allowed to make one guess, but if you are allowed to make 2 guesses, then you make range of guesses, it will be between these 2 numbers. Right? So that's what happened, right? When you go to each morning, when you switch on the TV, look at the financial forecast, right? You will see an expert, so-called expert, sitting there. The anchor asks, "What do you think about today's Hang Seng Index?" Right? If the expert is very good, they will say, "Oh, okay, tomorrow the Hang Seng Index is this X number." Okay, but so accurate usually must be wrong, right? But you will probably say, "Okay, tomorrow maybe 26,000 to 28,000." Right? Gives you a range. Okay. But if I'm not an expert, so if you ask me, they'll say it's between 0 to 10,000. Okay, must be correct, right? But I mean, of course, the smaller the better. So it just how big and small of this depend on how variation of this is this. Okay, so that would be the idea, right? So suppose my data is like from 0 say up to 6, right? I increase more. So if you run this, okay, the mean is still 3, but now the SE is 0.81, much larger. So because the data is more variation, so you need to have a bigger bump to bump the area, right? So and then of course, if your data is like more concentrate instead of this, right? Suppose you have 1.5 and 4.5, right? The data is more concentrated. Then if you run this, okay, your SC now is 0.6. So your guess will be much narrower. So then this is what you guess. Okay, so this is nothing new, but this you learn from your college already. So sorry for the number there. I should have changed that, but okay. I'm sorry about the mistake. Okay. Now, you can use a number there. Okay. There are 0.5% of days that has more than that loss. Okay. You can use the formula there. Total number of days is 25,000. And for binary data, because it's just like it is below 5%, negative 5%, or above negative 5%, it becomes 0 and data. Okay. You can actually use the formula there. You can calculate that. Okay. Or or you don't like this, you can just basically put the data there and ask them to calculate. You get the number there, same thing, okay? And then you can calculate, this is 0.14, right? So it's just 2 times of this, add and subtract, will tell you that is 0.2% and 0.7% is the risk, right? If you don't like this, you can give you this number, okay? So this is our guessing, right? So you are generalizing our data, right? Because the data don't tell you anything, but this is extent knowledge. We're saying that, okay, if you invest in the future, you tell your investor, this is the risk you're going to take, right? 95% of the time, this is the case, okay? And this is called the 95% confidence is 95% of time, this will be true. Of course, it can go outside, but that's 5% thing, okay? Is that clear? But I think you learned the 95% in your undergrad anyway. No? So what 95%? Okay. What does that mean is hypothetically in 100 universe, I do this procedure. Okay. Means that in 1,000 universe, I ask him to bump. Okay. 95 of this bump will hit the target. Will include what we want to do. Okay. And 5 of them will miss, but I don't know which one. Okay. So that's why we call 95% confidence interval. We don't know which one, but 95% is okay. We have the confidence in the process, this is right, but it's not probability. Okay? I don't want to go into the philosophical question, but this is what it is. Okay. And one thing we want to do is, okay, we cannot repeat the history, okay, because history has been done. But we can ask a computer to generate the history based on the data. So that's a technical method, okay? So what we're going to do is we ask the computer to fake the history, okay? And based on this, we create multiple universe and look at each universe, how many days you have lost more than 5%. And look at those days, and that will be your guess. Okay, that is the idea. Okay. One way to do it is you close your eye to pick the days, and this is a new history. And you calculate that many, many times. And then you calculate the statistic, you calculate standard error. And that will form what we want to do. Okay. So I talk about this. We'll talk about it next time as well. But I still have 2 minutes, so let me talk about this. So what we're going to do is we look at the data. I take 1,000 days. I close my eye, pick 1,000 days. They become a new history. And this new history, okay, I calculate the days more than 5%. And I calculate this, okay. But I'm not done. I create 1,000 of those days. Okay. I create 1,000 of parallel universe. And I look at, on average, how many days you see, and I can calculate the SD and so on and so forth. Okay. Don't worry about that. I'll talk about this next class. But what we're going to do in the next class is you are making the history. That's what we're doing by the data. Okay. So I will give you 2 minutes earlier as you want. So see you next week.